Hello everyone, welcome to today's lesson on linear systems problems. So for the past few lessons, we learned about the three different ways we can solve linear equations or linear systems. And now we're actually going to put them into use. Right? So what's the point of just having two equations and two variables at the same time? Right? We can actually use them to solve some interesting problems. So for our first question here, right, just a single line. The sum of two numbers is 752 and their difference is 147 or 174. Okay, so we got two pieces of information here. The first one is that the sum of those two numbers is 752, and the other one is that their difference is 174. Right? And that essentially gives us the two equations we are working with. Right? The first equation here is that sum of two numbers, let's say it's just x and y. Their sum is 752. And the difference, so equation 2, right, the difference just means when you subtract them, right, is 174. Right, and that's it. Right, now with this information, we can set up our equations. Right, and then from there, we can solve them however we like. Right, again, I usually prefer elimination, so I'm just gonna do that. Right, actually, I don't want this in green here. Right, so with elimination, right here, I can add those two, right, to cancel out the y here. We get 2x here. That equals to 960. Nope. 126. Okay, 926. Divide both sides by 2. We get x equal to 463. Okay, now that was 463 for x. Right, we just plug it. Right, we just plug it into one of our equations. Right, so 463 plus y equals to 752. Of course, to solve for y, right, we just subtract both sides by 463, which is 289. And that's it. Right, so x is 463, y is 289. Okay, and as usual, we can double check, right? The sum of those two numbers. Right, so if we add those two numbers together, right, that is indeed 752. And then their difference is 174, so I can check that. When we subtract those two numbers, right, it is indeed 174. Double checked. And so whenever we got those questions, we can always plug the numbers back into double check. Okay, next question. So Mr. C is saving up for his trip to Hyrule. In his piggy bank, he's got 300 coins, and there are the nickels or dimes, right? So that's our first piece of information. So 300 coins of either nickels or dimes. Right? And now we also know that all those nickels and dimes add up to $23.25. Okay, so now the question is, how many nickels and dimes does he have? Okay, so that's what the question is asking us, right? How many nickels and how many dimes? So we can represent nickels as n and dimes as d, okay, as our variables. Right, you can use x and y as well, but I'm going to use n and d so it's more clear. Okay, so how many nickels and dimes does he have? We know from our first piece of information that he's got 300 coins. Right, so the number of coins, right, the number of nickels and dimes must add up to 300. Because it's a number of them, right? N and D are the number of nickels and dimes. And second piece of information is that he currently has $23.25 saved up. Okay, so how do we represent that? Right, we know that a nickel is 5 cents and a dime is 10 cents. So what we can do is, okay, the number of nickels times 5 cents and the number of dimes times 10 cents need to add up to $23.25. Right, because again, we know that a nickel is worth 5 cents and a dime is worth 10 cents. Right, so if we just multiply each value by the respective number of coins, right, then we can add it up to check that it is $23.25. Okay, there we go. Once again, set symbol of equations. Right? We don't like decimals, so we can multiply everything here by 10 to get rid of decimals. Right? So our new equations. So n plus d is still the same. Multiply everything by 10. We got this. Right? Of course, we just subtract. Right? So we can cancel out the d. We get 0.5n equals to 67.5. Last step, isolate the n, which is 135. Okay, plug it in to one of our equations, of course. We can do the bottom one, but the top one is a much simpler to calculate. Right, we just subtract both sides by 135. Right, there we go. Right, of course, our answer now is, right, n is 135, d is 165. Right, but I have no idea what that means, right? Of course, at the beginning, we said that nickels is n, d is dimes, right? But the reader doesn't always know that, right? If you just give me x is this, y is this, then I have no idea what you're talking about, right? X could be anything, y could be anything. So whenever we give our answer, we have to specify what it is. So if n is 135, that means we have 135 nickels. And we know d is 165, so it's 165 dimes. Okay, so that's how we give our answer. In a previous example, we used x and y because it's just find those numbers, right? Those are literally the two numbers. But here, when we just have n is 135, we don't know what n is. Right? N could be anything. Okay, next question. So, Mr. C's play his favorite movie, How to Train Your Dragon. Absolute banger of a movie, or banger of a series, actually. First information, he charges $12 for adults and $8 for children. Okay, second piece of information, 300 people attended. Right, and we also know that Mr. C earned this much money, right? So we got a few pieces of information here. Right, and now the question now is asking how many children and adults showed up. Right, so that's what we're trying to find. Number of children, number of adults. So let's fill out variables. Let's say children is C, adults is A. Okay, so we know that, again, 300 people showed up. Or 300 people attended. So our first equation is similar to the last one. All right, it's just number of adults plus number of children is 300. Okay, that's it. Second equation, right? So similar to the nickels and dimes problem, right? We know that Mr. C here charged $12 for adults and $8 for children, and he earned 3,280 in total. Right? Which means that in this case, he earned $12 for every adult that showed up, and $8 for every child that showed up. Right? And in total, he earned this much money. Right, so that's how we can set up our equation. Right, we always remember what our definition of the variables are. If the A and the C in this case is number of people, right, then we can multiply to the ticket price to get the total amount. So in this case, we can just eliminate something. Right? We can multiply the top by 8, so we can eliminate the C. Right? But in this case, it's actually faster to just substitute. Because we can rearrange it to be A equals to 300 minus C. And I plug this A back into here, right? So we can use substitution here, which is a little faster. So it's 12 times 300 minus C plus 8C. Expand it out. Right, take the constants to one side. Right, we get minus 4C equals to negative 320. Right, of course, you just divide both sides by negative 4. So C is now 80, right? So 80 children showed up. Of course, we plug it back into one of the equations. I'm gonna pick the top one, so select calculate. Right, subtract both sides by 80. Adults is 220. Okay, and then we're done. Or actually, not done yet. Right, because we know A is 220, C is 80. But they literally mean nothing, right? Could be 220 anything. 220 chickens, 220 dragons, 220 whales. Right, so we have to specify is 220 adults and 80 children. Right, so always make sure to give your answer with the context in mind. Okay, so next are two very hard questions. They're both definitely extending level. I actually had to look up the answer key a few times because I even had trouble trying to figure out what this means. All right. But with most of our problems, the math itself, we practice a lot, so I don't think it's the difficult part per se. It's usually the part of setting up the equations that's the most difficult. Okay, so we got a small plane wants to make this trip. Right, so the whole trip is 2,400 kilometers. Right, and now first time it took him 7.5 hours to fly, but on a return trip, it only took the plane 6 hours to fly. Right, so you can kind of guess what the two equations are already. Right, but here's the last piece of crucial information. Right, the plane travels at the same speed, and the wind also travels in the same speed at the same direction. Right, so now I want to figure out what's the speed of the plane and speed of the wind. Okay, so once again, we use variables. The speed of the plane could be p, the speed of the wind is w. Right, and we know that distance is speed multiplied by time, right? Speed times time. Okay, so let's try to figure this out, right? We know that the trip, so the plane took two trips. There's one trip that the plane flew in 7.5 hours, and there's another trip that took 6 hours. Right, so we know that if the trip took 6 hours instead of 7.5 hours, right, the plane must be going with the wind. Right, because if the plane is going with the wind, then it's flying essentially faster, which means that it is or the plane itself is still the same speed, but with the speed of the wind, it's essentially carrying the plane faster through the air, right? Because the wind is behind the plane, blowing it forward. And in contrast, the trip in 7.5 hours is slower because the wind is kind of pushing against the plane. Right? It's like if you're on a beach or if you're swimming in the ocean, right? It's always harder to swim against the current instead of swimming with the current. Right, so it's a trip that took longer. The plane is going against the wind. Right, so again, the plane and the wind are traveling at the same speed. Or no, the speed are not the same, but the plane speed is the same, and the wind speed is the same. Right, they don't really change. But the plane can make the travel shorter if the wind is helping the plane, is boosting the plane forward. And the trip gets longer if the wind is kind of pushing against the plane. Right, so this is why those questions are extending. Right, this isn't just math at this point, right? We really have to kind of take it into our context. Right, so when we're going against the wind, we call this headwind. And when we're going with the wind, we call this tailwind. Right, that's why that moving Pokemon tailwind doubles your speed. Right, because if you're going with the wind, it's carrying you faster. Okay, so what does that tell us? Right, when we go against the wind, right, our speed is then reduced by the wind. Right, because you can imagine here's our plane speed, but because we're going against the wind, right, the wind's kind of slowing the plane down. Right, and if it's tailwind, you can imagine the wind is behind the plane, kind of boosting up further or faster. So this is all the information we need actually. Right? We know that if the plane makes the trip in 7.5 hours, its speed is plane speed minus wind speed. Right? Because yes, we're going against the wind. If the trip's in 6 hours, then it must be tailwind. Right? The wind is boosting the plane, but that's why the trip is shorter. Right? So we got the two equations here. The distance here in both cases are 2400. Right? That has not changed. It's the same trip. In the first case, right, the speed is p minus w, and the time is 7.5. Right? And again, we just multiply together. 7.5 times the speed. Right? In the second one, once again, distance is speed times time. The speed is p plus w, the time is 6. Right? I'm just writing the time first, just so it's easy to look at with polynomials. Okay, how do we solve this? Right, so what we could do is expand. Right, we can expand the bracket out, right, and then do all the elimination or substitution, all that. But alternatively, what we can actually do instead is we can just divide everything by 7.5 and then 6 for those two equations. Right, because when we do, if we divide every equation 1 by 7.5, we get 320 equals to p minus w, and the bottom becomes 400 equals to p plus w. Right? Because we know that we have to multiply the 7.5 to this bracket anyways, if we just divide it away, right, this essentially cancels out. And because of that, you can see here that it's a lot easier to calculate. Right? We can now just subtract the two equations to cancel out the p. Of course, right here, we divide both sides by w. Or not by w, by -2. To get w equals to 40. But as usual, we still gotta plug it in. P minus 40. We add 40 to both sides to get P at 360. Okay, so of course, we don't know what the variables actually are, so we gotta specify. The plane speed is 360 kilometers per hour. The wind speed is 40 kilometers per hour. Okay, there we go. Alright, so again, this is extended because not only do we have to know how to set up our system and then solve it, we also have to kind of know, like, why are we setting it up the way it is? Alright, this isn't just math anymore. This is more so kind of thinking about how different things interact and how do we set up your equations that way. Okay, here's another question. Again, also very difficult, but that's the fun part, isn't it? So we got two solutions, right, as a solution. We got a solution that's 50%. Another solution is 80%. Right? So a percentage solution just means how strong it is, right? If it's at 100% acid, then this is literally just a bottle of pure acid. Right? If it's a 50% solution, then this mixture is half acid and half water, for example. Right? So higher percentage, the stronger the dose. Right? So now, our goal here is to obtain 100 milliliters of a solution that's 68% concentrated. Right? So now we have to figure out what to do. Right? What's our variable? The question is asking how much of each solution. Right? So that's what it's asking, how much of each solution. So what that's essentially saying is how much of the 50% solution and how much of the 80% solution should be mixed together to make 100 mils, and the resultant solution is 68%. Okay, so our variable is then milliliters of the 50% solution and milliliters of the 80% solution. right? Because again, the question is asking about how much of each solution, which is actually saying how many milliliters do we need from each solution to mix it into 100 mils, and the solution of it being 68% instead. Okay, because we know the final solution, right? The final solution is then 100 mils of 60% solution. Okay, so let's set up our equations. Right, the first one is actually kind of familiar. Right, we know that because they're both milliliters of the solutions, when you want the end result to be 100 milliliters. Right, so we just have to add those together to make sure that the final solution is 100. Right? Okay, now the second equation is going to be more difficult. Right? We know the 50% solution is just 0.5 times the x, right? So how many mils of the 50% solution do we need? And how many mils of the 80% solution do we need? Will get us a 68% solution. Right, so this is how we will set it up, right? Because x is a number of mils of 50% solution, right? 50% solution. Y is a percent of 80% solution, or so the mils of the 80% solution, right? Which is here. And now our final product needs to be 68% solution, right? 68, 0.68. However, there's one thing you have to watch out for. The final solution is actually 100 mils. And notice how the x here, right, refers to just 1 mil of, or just mil of 50% solution, right? And if we want the final product to be 100 mils, right, we actually have to equate this to 68 instead, right? Because we have 100 mils of the final solution, right? We're not looking for just 0.68 of the solution, right? It's 100 mils of it. So we actually have to multiply our final, or I have to multiply 0.68 by 100, right? It's 100 mils. Okay, but then from there, that's just a quick little simple substitution problem. Right. Or maybe not quick because we got decimals to work with. We can scooch the y onto the other side. And then plug this x back into here. Okay, expand. Move the constant to the other side, combine like terms. Divide both sides by 0.3. Alright, that's y done. And then the x. Alright, subtract both sides by 60. X is 40. Alright, this means that we need 40 mils of the 50 solution and 60 mils of the 80 solution. Okay, there we go. Right, so like I said, those are two very hard extending questions, but this really tests the limits of what we can do with systems of equations. Right, again, solving the equation isn't the hard part. Most of it is actually setting up the equation and figure out how can we find the two equations. But with that being said, that's pretty much it for application stuff, so good practicing.